write Lewis dot structures for tin chloride, tin 2 chloride, and POCl3. I'm sorry to hammer this at you all the time, but I know how important it is to write good Lewis dot structures. Okay, so I'm going to look at this SnCl2 first. Tin has 4 valence electrons plus 2 times 7 for the chlorine. That's 18 electrons. Tin has lower electronegativity than chlorine, so I'm going to put tin in the middle and chlorine around the outside. And I'm going to put 2 bonds in there, so 18 minus 4 is 14 electrons. 14. And I'm going to start making octets. First I'm going to make an octet for this chlorine, using up 6 electrons. And then 6 more electrons to make an octet from this. So this is 14 minus 12 is 2 electrons. And the 2 remaining electrons have to go on the tin. Now, again, at this point, we have octets around the chlorine, but the tin has an electron deficiency. It only has 6 electrons. And you get into trouble. The formal charges with this are just fine. There's all zeros. If you try to make double bonds, they become unfavorable, just like we did before, and I'd like you to prove that to yourself. Tin only has 6 electrons around it, but it has good formal charge, so this is the description we would end up with for tin. Tin 2 chloride. POCl3 has phosphorus in the middle, and oxygen and chlorines on the outside. It has 32 electrons. And so we'll start off putting single bonds the way we normally do, and that's 8 electrons consumed, and that will leave 24 electrons to work with. And we'll use the 24 electrons to make octets. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So 24 minus 24 is 0. We don't have any electrons left. And this is the all-octet structure. But if you look at the oxygen's formal charge, it's -1. And the phosphorus formal charge is +1. And the chlorines are all 0. Okay? Now, phosphorus has Z greater than 12, so we might be able to make the formal charges better by taking a pair of electrons and making a phosphorus-oxygen double bond. So that would lead us to something like this. 2 pairs of electrons there, and then chlorine. Chlorine with 8 electrons around each chlorine. That's just a wedge showing you that one's coming out. These are going back. I can't draw that back triangle right, so a dotted line amounts to the same thing. So this would have a 0 formal charge on the oxygen. Double bonded oxygens are 0. And the phosphorus would also be 0. And the chlorines are all 0 still. And so this ought to be a better indicator of the hybrid for POCl3 than the one up here with the single bond. And it is. It turns out to be that.